Hey Dad. Hey, so here we go. Here is your sample, and this is from the field with the rams in it that had the rush patch in it. So collected from that rush pasture with like the kind of like nettle bed as well that was growing there. We found the snail in. So here we go, and so we're expecting to find some like slightly anaerobic soil, I suspect, because it's probably fairly waterlogged. Um, So this is the sample, and this is like at times 40, basically, or 40 times total magnification. So basically we're just having a wee look to see any of the sort of arthropods, nematodes you can spot at this magnification as well. So we'll just have a really quick little scan, and then we'll zoom in and see bacteria, see all these kind of like more filamentous organisms as well. And just try and get a wee bit of a grasp of what's going on in the soil. Um, so, like I told you, we're looking for these kind of trophic levels, right? Of trophic levels, but functional groups. So things we want to see are nematodes. We want to obviously see fungi. We want to see all the protists in all their various guises, um, and we want to see bacteria, and we want to see large diversity in all those groups. Um, there's some things we, of course, don't want to see, and that would be any of the very little movement so far, by the way. Any of the pathogens, so pathogenic species. There's a much larger percentage of pathogenic species in terms of fungi and bacteria, and in fact nematodes, that like to live in anaerobic conditions. So typically, anaerobic conditions, we're scouting past some hyphae here, I think. Anaerobic conditions give rise to many disease causing creatures. So, like in nematodes, root feeding nematodes, things that like root knot nematodes, those kind of classic agricultural pests, usually thrive in conditions where there's compaction and therefore little gas exchange. And obviously, if there's compaction, then oxygen is unable to diffuse, into the soil faster than the microbes that are living in the soil can use it up faster than it can diffuse in. So not a whole lot of movement so far. Just flying past all this stuff. All these various strands, apart from the one that you see in the center, which is actually a strand off my microfiber cloth when I clean the slide. um, a lot of these strands are plant roots, bits of organic matter, like this one. You can see that it's degraded around the edges, right? There's no clean straight breaks in it. There's no clean defined edge to it either. If I focus in and out a wee bit, you'll be able to see that. So these are all strands of organic matter, and I don't think that's a root. That'll be some cellulose, I should imagine. Like a stalk of a plant or a leaf of a plant. So the other things we can see at this magnification are like some of the larger fungal spores. So some of the more highly evolved fungi, like the basidiomycetes, um, anascomycetes, duromycetes. All these groups of fungi have quite large spores. So here's something quite noteworthy. This thing that's right in the center here. I don't have a pointer, I'm afraid. So yeah, a thing that's right in the center that's kind of honey colored. That's some organic acid that's been produced as like a secondary metabolite of fungi feeding. So that's a fulvic acid, and you just tell that by its coloration. That kind of honey colored tan, dark, well, light brown color. That is basically more complex carbon molecules that have been pulled together through the process of like fungal digestion and then expelled. So some fungi and bacteria have basically eaten and absorbed organic matter, expelled those nutrients. Something else has come along and fed on that, and then etc. etc. That's been that ball has been kept rolling, and we have this end product. So fulvic acid, and definitely an indicator of fungi, fungal presence. But we're really looking for humic acid, and that's that classic, huge air bubble here. Sorry about that. That's that classic soil, dark, rich color. So that's why soil that's high in organic matter is the color that it is, because it's got all these organic acids that are produced by fungal activity. So what we'll do is, I'm just going to scan really fast now, just see if anything catches my eye quickly. Obviously this isn't a proper sort of the speed you would go out for a proper assessment, but we're just trying to highlight a few things here. So no, can't see much happening. We would of course also expect to see possibly parasite eggs if you have a heavy parasitic load in your sheep. They would of course almost undoubtedly turn up in this soil sample. So that's how we zoom in here, see what we got. Right, so these are some of the first kind of elements we've got here. So any of the transparent window pane-like materials, they're all silica. I'm sure you know a lot of all this stuff, but like this one right in the center, that's a sand particle right there. These little particles are intermingled with organic acids here. Some of the very small detritus are clay particles, clay platelets. Let's have a look. So a lot of minerals in this soil, and we'll try and find something living. Let's just zoom back out and see if we can just quickly find a fungal strand, because there definitely was a few things worth checking out. Okay, so a simplistic version of the reason that we're looking for all these functional groups is, like I explained to you, the bacteria and fungi are essential in creating the soil structure that we're looking for through their formation of aggregates because of their production of glues. And then we're basically looking for the other trophic levels, like the earthworms and the nematodes, protists, because these are generally like predators. These are generally predators of the fungi and bacteria, and it's through the consumption and expulsion of the nutrients that these predators gather when they harvest, when they eat their prey, that expels nutrients in plant available form. It's like a little strand here of something. Looks quite dark and quite dark, rich colour. So you begin to see life suddenly. So this is definitely a fungal strand. You can just about make out, you see in the very top, you can just about make out a septa there, a wee cross wall, and you can make out a couple of divisions there, so you can make out one cell length in the centre there, in between those two septa. We got a sort of really nice dark rich brown colour as well, and hold on a second, my camera's just about to give out, so we'll back